Hello friends, so today we're going to discuss the problem B from the latest Codeforces round 699, problem name New Colony. So in simple terms, I'll tell you the problem statement. It states that you are given some sort of mountains or different heights, okay, and the height of the highest mountain is hi. Now you have different boulders. You can assume each boulder to be like a ball, okay, or not exactly a ball but like a slab. You can assume that each boulder is like a slab, okay. Now what you are doing here is you are standing on the first mountain, which is like the h1, and now what you actually have to do here is you will start throwing these slabs or boulders, okay, from this top of this mountain. But the slabs or these boulders will move on these mountains according to these given rules, okay. So now if the height of the current mountain on which you are is greater than the next mountain, then obviously the boulder will roll to the next mountain. I'll draw it you with the first example. As you can see, the first example is 4 1 2 3. Okay, so let's draw it out. Okay, just think that this is 4, this is 2. Okay, the 4 1. Okay, this is 1. Okay, then this is 2. Okay, and this is 3. Okay, they are actually not mountains, but let's assume that you are on the starting on the first, like, okay. Now if the current mountain on which or the building you are is greater than the next mountain, if you are like taking this ball, then if you let's say we push it to this side, let's say you just give a push, then obviously it will go down in this because it cannot go to this part, okay. But now because it go down to here, it will increase the height of this building because like you can assume, I also tell you that this is like a slab also, so its height is equal to 1. So because let's assume that this is 4, this is 1, this is 2, this is 3, then it will its height will become equal to 2 because this is a one slab building like a block. So it now, because it will fall into this part, and because the height of this is 4, this is 2, and this is 1, this is smaller, so it will as you can see, like stuck in this two parts, and thus the height of this part will become equal to 2, like the whole part, because it is 1 and 1. Okay, and that's what we are like explaining here. So it will become like 4 2 2 3. Okay, then if you throw the next ball, because it will go to this part, but now because the height of both of them are 2 2, it will keep on rolling to the last block at which it can get blocked. Okay, so as you can see, then because this is 2, it will go to this point, and now because it is like stop at this point, the height of this will increase by 1, so it will become like 2. So now the height of this will become 3 because this is 2 plus 1, which is 3. This is whole 3, this is whole 3. Now if you again throw a ball, because like it is again like a valley between these two buildings, it will again drop down here. The height of this will also become 3 here, so 3 3 3. Now if you again throw a ball, it will go to this side, because like it is flat. I will always tell that if the height of the buildings are equal, then it will always go to the right side. So you will throw a ball, it will go to this point, this point, this point, and it will go out of this bound. If it go out of this bound, now all the other ball will do the same. It will go out of bound, out of bound, out of bound, and so on. And thus you can easily see that if at a certain point it can become that after all of them, it can happen a case that after a certain scenario, all of the rest of the balls will go out of bound. And these are the two key observations. You have to first find out a turning point or like a pivot point after which every ball will go out of bound. So even if the k is greater than 10 to the 9, okay, it is like a very large number, up to a certain point it will, after a certain point it always go out of bound. And because as you can see, hi is very small, hi is up to 100 only, n is also very small, 100, but k is greater than, but k, because it's a turning point, it will not make too much difference. So what is actually in this point question here is, you are throwing out these slabs, so you have to find out at which point the kth ball or the kth boulder will land. Okay, maybe it, as you can see, this is the first boulder, the second boulder, third boulder, and after the fourth boulders, all the boulders will go out of bound. If the boulder out of bound, it goes out of bound, and I have to print out -1. Else you have to print out the index, and the starting index is 1 at this point in this question. So I have to just print out that. So now what you can easily do here is, because the values are very small, you can do a brute force for every boulder. What I mean by this is, because see, the maximum height, so let's assume you find out the maximum turning point for a boulder. So each boulder, as you can see, each height of this building, I'll draw it out, just wait. As you can see, let's assume that I have some small heights here, okay, like some small heights here, and then there is a big height building, and then there are small height building or so on. Okay, so now as you can see, if I'm standing on this part, I'm throwing out this boulder, this is smaller height. Okay, so the next height will become greater because this ball cannot go further, so it will go to the like current position. So the ball will remain at the current position if it cannot move further. Okay, so it will remove further. Now this height becomes same. So now if I throw out a ball here, it will go to this point. Now this is like a smaller and greater, so it will come to this point, then this point, then again this point and this point. And now if I again throw out a ball, it will go to the like in this manner and then drop out at this position, and then because it is greater than this, it will drop out and go out of this point. I hope you get the point. And after this, all the balls will go out of this one. Let's assume that this is greater like this, so it will fall into this pit. This pit will get bigger and bigger and bigger, and then it will then after it will go out of bound. Maybe this height and this height are same, so it will go in this pit. And after that, as you can see, the maximum case can happen that all the heights can become of the same height as the maximum. So the maximum case can be that all the heights of these buildings will become equal to the maximum height of the building. After that, because it cannot happen that like my height will become greater than the maximum height. Okay, that case is never gonna happen. And thus the maximum height will be that whatever is the like the maximum number of balls I will require is like the maximum in this is like, if you find out the maximum height of all of these building, then find out that okay, the height of this building is this, so how much balls are required to make it the maximum, like this. How much balls are required to make this the maximum, this, and add them up. And this is the maximum number of balls we are required in max. Okay, so that after that all the buildings will become at the same height, and that in after that case all the balls will go out of bound. So because if every height is at 100 and all the maximum number is also 100, so it can be done because the maximum time complexity for this is O of n square. Okay, so now that it can be done in O of n square also, because h is small and t is also 100 only. Okay, so no, like this is fine. Now what you can easily do in this problem is how you can find out the ith boulder position. So this is also very fine. Just take out each ball and like try to roll it down. Okay, if the height of this ball, like this height, is smaller than the next height, then this ball will come to this part only. So make this ball come to this current tower and increment the height of this tower to this point. If this height is greater than the current, like the next height, so take the boulder to the next height, and so on. Keep on doing this. Keep like for every ball, keep that ball and try to iterate it over the whole field, which means that okay, maybe the next part is this. So take this ball, maybe it will go to this part, and it will go to this part, and it will go to this part, and maybe it can go out of bound. If it goes out of bound, and let's break out because all the balls will go out of bound. Okay, but if it not goes out of bound, like maybe this part is this, so this ball will go to this part, and the height of this you will increment by 1, and now you'll do the same for every ball. And then you can find out that for every ball what is the kth position it will land, and just print out the value for the kth ball. Okay, and that's the logic for this problem. I'll show you the code part now to make it more clear. So you have to just find out first what is the maximum k. So you can also like find out that position. So what you can do here is, this is n and k. Okay, find out the maximum among all the elements. Okay, this is left, how much elements are left to make it all equal to the maximum element. So iterate over the whole array and then find out a difference between the like maximum minus a of I. So for every position, if it becomes equal to maximum, how many balls are required, and add them up. If k is greater than this left means how many, like if k is even greater than how much required to make all the levels equal, then obviously the answer is -1, because after that case all the balls will go to the waste. Okay, so the answer is -1. Else the answer is -1. Answer means that okay, my initial answer is -1. For all the balls from 0 till k, find out. This is fill. Fill means that okay, whether this ith ball, like whether this ith ball is filled in some position or it goes out of bound. Okay, so that's so first it is 0, then iterate over from 0 till like n-1 position, and if for every ball what we are checking that if the like this is smaller than the current position, like the j and j plus 1, if the current height is smaller than the like the next height, then obviously this ball will not go further because the current height is smaller and the next height is greater. So the ball will land on the jth position. So the land will land on the jth position. The answer will become j plus 1 because these are from 0th indexing, and because my ball land on this position, my height of this boulder will increase the height of the current ball position by 1. So a of, like, because a is storing out her heights, so a of j plus plus, and because it is filled, so fill is plus 1. Okay, and then they just break out of this loop because this ball is filled. If fill is like fill is 0, which means that this ball is not filled, it goes out of bound, then the answer is -1. And then we are finding out it for all the values, and when we finding out for kth value, because this is the last value which we are finding out for k, you can also, because I'm actually storing out for all the values, but I'm not storing out for every value in some array. Okay, I'm overwriting it again and again such that the last value will be the final value which is stored here, and that's what we are printing the answer. I hope you understand the logic as the code. The code will be in the description, so if you have any doubts, you can mention in the comment box. I'll see you next one. Till then, keep coding. Bye.